Hello everybody and welcome back. Root Beer here with more of the 2000 Cayley paper. We're on to question number 16. So we're over halfway done part B. In the diagram, ABCD is a rectangle with AD as 13, DE is 5, and EA is 12. So immediately something that triggers to me is 13, 5, 12. These are the side lengths of a right angle triangle. Which the first few Pythagorean triangles are something that you should probably be familiar with if you're seriously trying to write these contests as best you can, and eventually going for some of that scholarship money that you can get in the future. But if you're just doing these for fun, a pattern that you will notice is that triangles like the 5, 12, 13 triangle do come up a whole lot. And the fact that this triangle will be right angled is probably going to be important to the question. So, we have these lengths, and we're asked, what is the area of ABCD? Okay. So, I can see at least two ways to do this question. First way would be, you don't realize that this is a right angle triangle, that AED is a right angle triangle. And what would you do in that case? Well, you would probably want to figure out the other length. We know AD. All right, we'll just draw our little picture. We know AD is 13. If we want to figure out the side length, we need this x here, 13x. And we're told, this is 5 and this is 12. Well, what we could do is we could find this altitude right here, and that's going to be the same value as x. And we could say, okay, x, you've got to split this guy into y, and 13 minus y, and use these equations to figure out what y is, and then figure out what x is, and that is a perfectly valid strategy, because you'll have 5 squared equals x squared plus y squared, and 12 squared is equal to x squared plus 13 minus y squared. So if you take equation 2 minus equation 1, you can solve for a value of y. You'll get a quadratic formula, I think, in terms of y. Or, no, you'll get a linear term in terms of y, and then you'll use you can plug this y back in here and figure out what the x value is, and then you'll say 13 times x is the area of ABCD. And that's an excellent strategy, it really is. But if you know that 13, 12, and 5 is a Pythagorean, and I'm not going to write out the calculation that shows this, because if you don't believe me, that's fine. Use this other way. A, B, C, D. So triangle AED is right angled. Okay. So if we have a right angled triangle, it's actually pretty easy to do some calculations with it. In particular, we can find area. Actually, let's just call this H. Okay. So, what our solution is going to come down to is the fact that if you draw a rectangle about a triangle as closely as possible, and then the area of that rectangle is going to be twice the area of the triangle. So the area of ABCD is 13 times H. This is the height of both the triangle and the and it's also the length DC. So the area of AED is 1/2 base, which is 13, times height. So the rectangle is twice the area of the triangle AED. But AED is right angled. So we'll go over to the next page. So if we just rotate the whole thing on its side, AED, it's 1/2, and now we have a different base and a different height, but we're still going to get the same value, so it's going to be 1/2. 5 times 12, that's 60, so we should get 30. And we know ABCD, the rectangle, is twice the area of this triangle. So it's twice 30, so we should get a final answer of 60. All right, and now we didn't need to do a whole bunch of squares and that sort of calculation and try and figure out what x is. We still don't know what h or what x, if we want to use the first example, we don't know what that value is. But that's okay. Seeing that it's a Pythagorean triple means, well, we don't need it. We just need to realize, oh, there's a relationship between the area of the rectangle and the area of this triangle, and since it's a right angle triangle, very easy to come up with the area. So 60. That's an answer of B right there. So hopefully you will take to heart that you really should learn the first few Pythagorean triples. 3, 12, 13, or sorry, 5, 12, 13 is one of them. 3, 4, 5, 8, 15, 17, 6, 8, 10. These pop up all the time. That said, if it's not something you immediately saw, there was an alternative for you, and it's not all that bad calculation-wise. X will have to be 60 over 13, but you know, that's not the worst number it could be in order to work with things. Okay. However you chose to do it, we get an answer of 60, which is fantastic. And yeah, that's really all I have to say about that. In the next question, we're going to be looking at question number 17, so we'll see that in the next video. So join me next time for question 17.